Hello everybody and welcome back. Root Beer here with question 18 on the 2017 Fermat papers. Thanks for joining me. For any positive real number x, the floor of x, that's how we pronounce that, denotes the largest integer less than or equal to x. For example, the floor of 4.2 is 4, and the floor of 3 is 3. Another nice example is the floor of negative 2.7 is negative 3. It works not quite as obviously with negative numbers. Okay, so what have we got here? If the floor of x times x is 36, and the floor of y times y is 71, where x and y are greater than 0, then x plus y equals, and we have a whole bunch of fraction options. And this should make sense. For example, the floor of y has to be an integer, so y is 71 over an integer. Okay, same sort of thing with x here. It's got to be 36 over an integer, so it's going to be a fraction. Whether or not it turns out to be an integer as well is a different story. Now, there's nothing I can see with these floor functions in here. There's nothing I can see to do to just get x plus y to drop out naturally. So I think we're going to have to work out x and y on their own. Okay. So what can we do? Well, in general, what we've got here is a nice little setup where we've got the floor of z times z is equal to some number n. And that's the setup for both of them. Just x and y have different n's, basically. How can we get a handle on this? Well, the floor of z satisfies a very nice inequality. It's always less than or equal to z, but z is always less than the floor of z plus 1. It's got to be less than, because there's no other integers in this range. It's one integer and then the next integer. Z's got to be between the two of them. And it's less than, not less than or equal, because if z were equal to floor of z plus 1, then z would be an integer and its floor would just be itself. So, okay. Now you say, all right, that's a nice relationship, one that I should know. Same with the ceiling of z satisfies similar relationships. It's the lowest integer greater than or equal to z. But how can I get this expression here? Well, I've got my z. Let's multiply everything by floor of z. So we'll get floor of z all squared, less than or equal to floor of z times z, less than or equal to floor of z squared plus floor of z. All right, and so this value in here is our n. So now we have a range of values for n. And what we can do is we can make a little chart here. So we can get floor of z, we can get floor of z squared. Now floor of z has to be an integer, so it could be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. We shouldn't be going any further than that. We can get both its square and the other expression here. And this will give us a nice little sort of range of values. And depending on where our n's lie, 36 and 71, that will tell us what the floor of our number should be. And of course, then we can rearrange. And z is n over floor of z. So, for example, 1 squared, and then 1 squared plus 1 is 2. Okay. 2, we go from 2 to 2 squared plus 2, which is 6. 3, we go 3 squared, and then 3 squared plus 3. So it's, sorry, this 2 squared is 4, isn't it? Yeah. So 9 and 12, we can get 16 and 20, 25 and 30, 36 and 42, 47 or 49, and then 49 plus 7, 56, 64, 72, 81 and 90, and 100, 110. Okay. Now I notice that our n for 36 is in this range. Okay. So that tells me floor of x is 6. And so x is 36 over 6. X is just 6. Okay. And We also have our n for 71 is in this range here. So that tells me the floor of y must be 8. And then y itself is 71 over 8, which I can't really express nicer than that. It doesn't simplify. But now we can do x plus y. It's 6 plus 71 over 8. I'll change that to 48 plus 71 all over 8. And that's going to be 79 plus, so it's going to be 119 over 8. And that should be our final answer here. And 119 over 8 is B. So B is going to be our answer for question 18. So we got 2 more questions to go in part B. Our next question in the next video will be question 19. I hope to see you there.